Hi guys, this is David Scher. I'm talking now about question 3 from exam 2 review for CSC260. So, this one is a somewhat simpler question, but it's a little harder because it's in the stack machine, which is a more efficient machine, but it's better suited for computers, compilers, and so on than for humans to write it. Anyway, so we're going to write for sal.ucode. So you got right. You're going to take the top 3 bytes of the stack, and you're going to replace it with the largest of those bytes. So we eliminate all 3 bytes, replace it with the largest. Once again, I wrote the code. When I wrote the code in advance and debugged it. I made all sorts of silly errors, like not putting the 0 zeros at the end and so on. And it took me a little while to figure out the right code. I'm going to show you the right code now. Now, your code doesn't have to compile or anything, because you're not writing in front of a computer. You're just writing it on paper. So you don't have to do such a beautiful job. Comments, on the other hand, are really important. So we're going to see. So I'm scrolling down. You saw the question 2. Answer sal opcodes. So once again, bring your sal opcodes list. Either, copy it from the class notes. I'm going to put all of the I'm showing you now under the class notes, or copy it from, or take the file in the MythSim documents with the MythSim opcodes. So these opcodes run a little different. They're basically all of these opcodes. Once again, I can't remember them off the top of my head. Look at them. In this language, the location, instead of occurring before the opcode, is after the opcode. And it's built into the opcode what registers we're dealing with. So when we push to R0, there's a different opcode for pushing to R1. There's a different opcode for pushing to R2, and popping to R0, popping to R1. Almost everything aside from the pushes and pops works with R0 and the top of stack. Okay. Now, this code always starts with the location at the top of stack. I'm going to put 200, 255, or 56 entries is enough for a stack, I feel, for anything we're likely to do. And -5 will be the initial top of stack. So I'm going to push a -7 onto the stack, and I'm going to push a -3 onto the stack. This is actually, okay, that's what my code, the last version of my code did. So I should end up with -3. Now, I also tried the version with 573 on it, and it worked correctly too. So, right. Now we're going to push. So now our stack has 3 items, and now what I'm going to do is find the largest of those 3 items. Now this code will work. Aside, we can change this part up here, and the code should still work no matter what those 3 items. So this is where the real answer to the quiz is. So first I'm going to dup. That means push another copy of the top of stack. That way I can push the top of stack. That'll be our largest candidate into R1. So R1 is going to hold the largest candidate, and the top of the stack will be R0. So now the top of stack has the second item on the stack. I'm dumping it and putting the second item in the stack into R2. So everything is floating around, and I'm using these opcodes here to do that. Now I'm subtracting, so the top of stack still has, so there's a place where I can get if I change the larger, R2 will be the larger I'm changing. Now I'm going to sub R2 from the alternate candidate, and that means from the top of the stack. So, and I'm going to jump if negative, that is if R0 was the larger one than the current top of the stack. And if it is, I'm going to push R2 onto the top of the stack. Probably should push R0, but R2 works as well. This code is probably more complicated than it really needs to be. Now I'm going to pop a new largest into R1. So that takes from R2 our new largest and pushes it onto R1. Pops it onto R1. And then I'm going to get rid, there was a difference right now, was on top of the stack, get rid of it. And I'm going to throw it into R2. It turns out there's no straight, just get rid of the top of the stack. Maybe that'll exist in some other version. Right now, you got to put the top of the stack somewhere, so I'm just shoving into R2. Now I'm going to pop the new candidate for the largest into R0. I'm going to push the current largest I found, R1, and I'm going to subtract them. And I'm going to jump if R0 is larger. Otherwise, so I'm going to jump if R0 is okay. Now if R0 isn't larger, I'm going to get rid of the distance. I'm going to put R1 on top of the stack, the old larger, and I've done it, so I just halt. Otherwise, I get rid of the difference, and I put R0, the new larger, on the top, and I halt. So either way, I halt with the largest item on the stack. And I've tested this code, right? Once again, we can go to this sim, and I'm going to open this guy with sal.ucode this time. So, and with review question 3. Where is it? Question 3. .map. Oh, come on. Open. And we can see this code doing its thing. So, this is -5 on top of the stack. Then I'm going to stick -7 into R0 and shove that on top of the stack. And then I'm going to shove a -3 and shove that on top of the stack. And now my stack is set up, and I start running the code. Start monkeying around. R1 gets the -3. And that's going to end up, we're going to see not much happening. We're testing the thing, and R1 is going to keep -3, you see, as long as we run the code. And finally, the top of the stack is -3. Now, if I change the code a little bit, so I change all of these guys to be the positives numbers. Instead of negative, I'm going to make it positive. Okay, and I run the code again. So I save the file, and I run with them again. Reload everything. And I'm just going to be lazy. Well, actually, I'll just... Here's 5. Now it's 7 on top. Now it's 3 on top of the stack. Now we monkey around. This 3 goes into R1. We bring in a 7. It notes that 7 is larger than 3. And now 7's in R1. Clears out the... Yeah. Now it reads 5 into R0. It checks that against R1. And it realizes that's better. And it terminates with 7 on top of the stack. And you can try that out with all sorts of different combinations. It should work regardless. And so that's the answer to question 3.